Okay, let's go ahead and start with chapter 1, section 7, which is more on algebraic expressions. For this first part here, let's just kind of go through some examples here of a written phrase and kind of write it out as an expression, an algebraic expression. So we've got 5 times x increased by 12. This one's pretty straightforward. So 5 times x, I'm going to do 5x. I'm going to write it as much as in an algebraic way as I can. I mean, I could write like 5 times x. That's a kind of a clunky way to write it, but yeah, so 5x increased right there. That word means plus, right? So increase plus 12. That's it. All right, so you can't do any more to that. We're just writing these out as expressions at this point. Triple the sum of a number and 6. Now, uh, this has a word in it that is a very much like, it might seem like a totally throwaway word. It's a conjunction, actually, and it's the word and. Okay, and the word and in this context, in this, for this particular expression right here, what that represents is that we're using a type of grouping symbol. Now, the word and sometimes just means and, right? Sometimes you don't really have to overthink it. It just means what it is. But in this case, it says triple the sum of a number and 6. So both 6 and the number are grouped. They're in together. So a number, oops, let me do this. A number and 6 that's what we're kind of talking about there. So, and then triple means 3 times, right? So 3 times a number and 6. And by the way, it's a sum, so that means we're adding. So something like that. So 3 times, and then n plus 6 is in parentheses. Yeah, like I can totally understand where people are coming from. That word and in some expressions, just like you can totally look past that and like, oh, it doesn't mean anything. Well, in this case, it does. Kind of means a lot. And it's kind of important in terms of how we write it out as an expression. All right, for C, the product of 8 and a number, all right, decreased by 10. Now this has got and in it, but in this case, it's just a product of 8 and a number. So that just means we're just doing 8n. The product of 8 and a number decreased by 10 means minus 10, right? I mean, if we want to put parentheses around that, you can. Doesn't really change or affect the problem in any way. But that's an example where and just kind of is what it is, All right, let's get into evaluating. Now, a lot of evaluating is basically just substitution. All right, so substitute. So evaluate an expression by subbing in. So substituting the variable, whatever the variable is in m or n or a or b or x or whatever it is, y, with its numerical or numeric value, its number value. Okay, so that's what we're going to do. In this case, in this example A, we have m equals 6, and we also have n equals 3. So that is what we're going to do. So we're going to put in place of m, we're going to put 6. Okay, that's what we're going to do. All right, in place in place of n, we're going to put 3. See how that works? All right, and then we're just going to follow order of operations as much as we can. So here, we're going to do that first. So 6 squared actually is 36, right? And here, I'm going to take it slow and steady here. So 36 minus 6, all divided by 3. 36 divided by, 36 minus 6 is actually 30. Kind of go down here. Divided by 3 is 15. All right, that one's finished. All right, same thing for example B. So for example B, we're going to go through and I'm going to square A minus 3 plus 2 to the third power minus B. And so A is 5, right? So I'm going to put a 5 there, and B is 2. So we're going to do the top and then see how that kind of comes out. And we're going to divide it by 2. All right, so you got, so 5 squared is actually, so let me just make sure I'm explaining this. we're going to take care of the parentheses first at this point. We're going to do. All right, and so 5 squared is 25. So 25, and just doing my slow and steady thing here. Actually, we could also do this. I can do this while I'm writing it all out. So 2 to the 3rd power, because that's kind of independent of itself. So it doesn't really affect the problem if we do that part, before we actually finish the parentheses. Because it's kind of its own thing. It's so 2 to the 3rd power is 8, right? 2 times 2 times 2. All right, all over 2. All right, now 25 minus 3 is 22. All right, we'll do that. 22 plus 8. I'm just rewriting the whole thing. 22 plus 8 is 30. All right, and then 30 divided by 2 is 15. Okay, we're done with that one. All right. All right, next page here, part 3, distributive property. That was a huge thing. This is a big deal in algebra for sure. So using the distributive property is most useful when the operation in parentheses cannot be simplified. I mean, you could use it when it can, but I would say algebraically, it's more useful when the parentheses, like when you have something in parentheses, like these examples right here, you can't really do m minus 5. You can't do a minus 8 or x plus 9. There's nothing you can do to those. So you have to resort to the distributive property. All right, so when you're distributing, what you're going to do is you're going to multiply the value outside parentheses into all values inside the parentheses, not just what's closest, not just the first value, but all values. All right, so that is what you're going to do. All right, so we're going to distribute the 4 into the m. In other words, we're going to multiply 4 times m, and we're going to distribute the 4 into the 5. Or in other words, multiply 4 times 5. So 4 times m is 4m. That's all there is to it. When you multiply a number times a variable, you just kind of meld them together. They become like one thing. They become a term. That's what it's called. All right, 4 times 5 is 20, so just minus 20. So 4m minus 20. All right, we're going to do 2 times a, 2 times 8. So 2 times a is 2a. 2 times 8 is 16. All right, kind of going through these. If you want to try these on your own, just pause the video and just skip ahead, because I bet you get this. All right, 6 times x is 6x, plus 6 times 9 is 54. All right, 8 times 9, 8 times n. 8 times 9 is 72. Okay, they're using the same color here. 8 times n is 8n. All right, now keep in mind, like when you're doing these, keep in mind, we are through. Like we cannot add any of this, right? 2a minus 16, you cannot subtract that. This does not make 60x or anything. This does not make 80n. That's it. You're done. A lot of times, I think sometimes what some people say to me is, it looks like another math problem, which is kind of true. It looks like there's more to do in a way, right? It looks like there's more math to be done, but we really cannot do anymore. The point of the exercise that we're doing right here is just to distribute. Knowing how to distribute, super, super important, in terms of algebra, really is, right? Lots and lots of algebra problems involve a step which, assumes you know how to do the distributive property. All right, this one we're going to do 5 times n and then 5 times 2. So 5 times n is 5n. 5 times 2 is 10. And then there's a 10 hanging out here. Now I should simplify this even more, because those are right here. These are like terms, right? Those are like terms, which 10 plus 10 makes 20, right? That's what that makes. And I'll write it right here. So you got 5n plus 20. And that's it. That does not make 25n or 25 anything. It's just 5n plus 20.